So what happens is we use what's called a gravity assist. We come back from the asteroid belt, come back toward the Earth, and we fly by the Earth, and we actually gain some momentum from the Earth. So we get that speed given to us, and that allows us to reach Jupiter. It takes us about 2 3/4 years after we fly by the Earth to get to Jupiter, and we're moving probably about 93,000 miles an hour.
All this is so weird. How can this possibly be true? How can the spacecraft gain energy from nothing? Well, check this out. To understand gravitational slingshot, we will consider this analogy. There is a train coming towards the platform at 50 km per hour. A boy throws a ball at 30 km per hour towards the train. All this is relative to an observer sitting on the platform. The train is moving at 50 km per hour and the ball is coming towards it at 30 km per hour. So this means that the train driver sees the ball coming towards the train at 80 km per hour. Then there is a collision, and it is an elastic collision. This means that the ball has the same velocity before the collision and after the collision. So the ball bounces off the train at 80 km per hour relative to the train driver. But wait a minute, if the ball is going away from the train at 80 km per hour and the train itself is going at 50 km per hour, this means that the velocities add up and the ball is going at 130 km per hour relative to the observer sitting on the platform. We can now translate this analogy into space. But before that, don't forget to like and subscribe the channel. We will understand this topic in steps. The spacecraft enters the sphere of influence of the planet with some relative velocity to the planet. As it reaches the perigee, its direction will change into the direction of motion of the planet. The spacecraft leaves the sphere of influence of the planet with the same relative velocity that it entered with. Because the planet has velocity in some direction and the spacecraft is also moving in that same direction with some velocity relative to the planet, we will add the planet's velocity and the spacecraft's relative velocity to the planet to get the final velocity of the spacecraft relative to us humans on the Earth. You see what happened there? The spacecraft entered with some velocity and added the planet's velocity to itself. For example, if the planet has 3 km per second worth of velocity in the horizontal direction and the spacecraft has 1 km per second worth of velocity in the vertical direction, when the spacecraft reaches the perigee and its direction changes into the direction of motion of the planet and it leaves the sphere of influence, then now the relative velocity of the spacecraft to the planet has become 1 km per second in the direction of the motion of planet. But consider this, the planet is also moving in the same direction with 3 km per second. So relative to us, the velocity of the spacecraft has become 3 km per second plus 1 km per second is equal to 4 km per second.